All right, so we're going to start off by our talking of probability by looking at a few questions from the textbook. Okay, so if you have your textbooks with you, turn to page 172. Okay, and we're going to be answering a couple of questions from there. You don't even need a piece of paper. You can just, I'm not supposed to teach you to write things on the textbook lah, kan? But yeah, so I guess you can write it somewhere else lah. All right. So let's take a look at question number 1 lah. Just to get an idea and just to remember kembali apa maksud sample space and yada yada. So a letter is chosen at random from the first 10 letters of the alphabet. Okay, using set notation, write down the sample space for this experiment and state the possible number of outcomes. So there are two things that you got to state here. Number 1, what is the sample space? Number 2, how many sample spaces there are. Okay, so whenever we write sample space, okay, we write it as big letter S. So, sorry. Okay, we write big letter S, and because we're using set notation, okay, so we have the, what do we call this? The squiggly lah. Okay, so first 10 letters of the alphabet. Everybody knows this. Okay, first 10 letters of the alphabet is Alif, Bata, Sa. No lah, your head. Okay, sorry. That's different alphabet altogether lah. Okay, but we're going to use A, B, C, D, E, F, G, H, I, okay, J. Okay, so this is our sample space because the question is letter is chosen from the first 10 letters. So that's the sample space. You want to choose one letter. Okay, so the number of possible outcomes. If you want to choose one letter, the number of possible outcomes, okay, which we are going to write it as number of sample space, okay, which is 10. Okay, so the point of this question is to teach you how to write sample space and how to write the number of outcomes, the number of possible outcomes there are. So we call it NS. N stands for the number of sample space. Okay, if it is number of whatever event, that's a different story lah. Okay, so one day I really need to learn the yang huruf-huruf Jawi. I cannot get beyond Alif, Bata, Sa, Jim, Ha, Ho. Is it? I can't remember. Okay, sampai situ saja saya ingat. Lepas itu saya lupa sudah. So yeah, maybe somebody has to teach me lah, so that I can like, oh okay, dia tidak cakap alphabet apa ni. Maybe we should use a Sanskrit alphabet ke atau. Okay, anyway, lame joke. All right, number 3. In an experiment, a coin is tossed thrice. Okay, so kamu ada duit shilling yang dilambung 3 kali. Okay, and then whenever you lambung duit shilling, okay, so there may be some smart people in our class. So whenever you lambung duit shilling, it's either going to fall head or tail. Okay, so we call this head, H for head, and T is for tail. Okay, some people call it kepala dan ekor. Some people call it bunga dan nombor. Some people call it gambar dan nombor. Okay, but we usually in mathematics, okay, we usually call it head and tail, which is kepala dan ekor. Okay, the kepala refers to the gambar and the ekor refers to the number, the side that has the number. Okay, that's usually the standard. Okay, kepala dan ekor or head and tail. So if HTH represents an outcome, okay, one outcome where the first toss is heads, the second toss is tails, the third toss is heads, determine the sample space. Okay, so let's go right into it. How would our sample space look like? Okay, the first one, wow. Okay, so the first one, the sample space, okay, the first one can be maybe all 3 are heads, H. Okay, that's one sample space. Because first time kau lambung, kepala. Second time kau lambung, kepala. Third time kau lambung, kepala juga. Okay, then what else? Can be maybe H, T. Okay, H, T, H. Or T, H, H. Okay, now in this case, the arrangement matters. Because the first time you get kepala, the second time you get kepala, the third time you get ekor is different from the first time kau dapat kepala, the second time kau dapat ekor, and the third time kau dapat kepala. It's very different. Okay, so when you play around with this, HHH, HHD, HDH, DHH, apa lagi? What else can we get? See, there should be 1, 2, 3, 4, 5, 6, 7, 8. There should be 8 altogether. Okay, so okay, TTH, apa lagi? You can just type out your answers in the chat. Apa lagi? There should be 3 more. HHH, HHD, HDH, DHH, DTT, okay, THT, all right. The last one is TTT, okay, TTT, one more. One, two, three, 4, 5, 6, 7, yeah, one more. There's one more that is missing here. TTH, okay, HTT, so HTT, all right. So you have our sample space. So these are the possible outcomes that can be when you lambung this one twice, 3 times. Okay, so determine the event A. Okay, this is a specific event. Okay, di dalam sample space ini yang kita sudah dapat. Okay, there is a certain event. So of obtaining at least 2 tails, sekurang-kurangnya 2 tails. So this is a specific condition. Ini satu syarat yang telah ditetapkan dalam soalan. The event A is getting at least 2 tails. So look at our sample space. Look at our sample space. Okay, which event in our sample space, okay, yang boleh memenuhi syarat untuk event A, which is at least 2 tails. 2 tails here? No. 2 tails here? No. Mana. Here. Okay, so it's T, T, H. Apa lagi? Oh, sorry. Squiggly ya. So kita mau. Okay, T, H, T, H, T, T, and T, T, T. Sebab dia cakap at least 2 tails. At least 2 tails means sekurang-kurangnya. Means 3 tails also is included. Okay. So the main thing, okay, it looks like apa ini? Ini macam bukan admit so macam senang betul. But the point is this: I want you to understand the concept, the difference between sample space and event. Okay, and then on. Oh dear. Okay, an event is always a subset of the sample space. Okay, so dalam kalangan sample space ini baru kita boleh timbulkan the event. Always remember that. Okay, the event can never be more than the sample space because sample space is semua kemungkinan kejadian yang mungkin. Semua kejadian yang mungkin. All possible events, okay, are in the sample space. That's why it's called a sample space. Okay, an event is sebahagian daripada sample space. Very, very important for us to remember. Okay, once we understand this concept, then probability is, you have won already. Okay, always remember this. All right, let's take a look at question number 4. Now we're going to look into finding a probability of one event. Okay, let's talk about one event first. So, question number 4. A bag contains 5 red marbles, okay, and 3 blue marbles. Okay, if Junaida pulls out a marble at random, pulls out one marble, okay, from the bag, what is the probability that it is red? Okay, so the long version of this, okay, if you look at our sample space, okay, the sample space is red. Sebab dia mau ambil satu saja bahkan, so you can get, 5 red and 3 blue. Okay, so since there are 5 red, 3 blue, so everything is a sample space. Sebab kau mau ambil satu saja. Okay, now but the question now is saying that the event is that you pull out a red. So the possibility of this happening is 1 red, 1 red, 1 red, 1 red, 1 red. Since there are 5 reds altogether. So the probability of a red okay, is how many reds are there? There are 5. How much is our sample space? Our sample space, stop annotating. Our samples, our sample space is, okay, our sample space is 8. Okay, our sample space is 8 because 5 over 8, and that's how you do it. Okay, dia bukan oh okay, if they pull out a marble and it's red means 1 red out of 8. Doesn't make sense because there are 5 ways to get a red color marble. Okay, so we need to take into account. Sebab kau pilih ini, this red marble is different from this red marble. Okay, that's how the understanding of probability is. Okay, so the number of ways to get a certain event, 5, over the number of sample spaces there are. Okay, a very common mistake. Okay, satu kesilapan yang biasa, ramai orang suka kumpulkan all the marbles together. So dia cakap, oh red and blue ni. So since ada 2 warna saja dan pemilihannya adalah satu warna daripada 2 warna, so kebarangkaliannya is 1 over 2. Okay, kalau kebarangkalian, if the probability is 1 over 2, this actually means this is a 50, yang kita panggil 50-50 lah. Okay, 50-50 chance. Kau ada 50-50 kebarangkalian untuk mendapat guli warna merah, which is wrong. Because there are more red marbles than there are blue marbles. How can you have a 50-50 chance? Kan? Okay, so which is why you need to take into account how many red marbles there are and how many blue marbles there are. Okay, you cannot just group them because they're the same thing. We don't look at it that way. Okay, each red marble is individual, is different. Each blue marble is individual, it is different. Okay, so never make this mistake. Kasih kumpulkan warna saja. Okay, that's not true. Because kalau kau tengok, ada lebih banyak merah daripada biru. Okay, this is a very common mistake. Sebab dia fikir warna saja, dia tidak fikir biji. Okay, I heard that. Sorry, never mind, forget it. Okay, question number 5. Each letter of the word number, okay, is written on a piece of card and placed inside a jar. Now, if a card is drawn randomly from a jar, so you want to choose one card, okay, what is the probability of drawing a vowel? So, same thing. Sorry, for those of you who are good at this, I'm still going to do this the slightly longer way just to give you the example. So, our sample space is N, U, M, B, E, R. So how many sample spaces do we have? We have 6 sample spaces. Okay, so we know that our probability is always per enam, must. Okay, so probability of drawing a vowel. This is the event. Okay, the event is drawing a vowel. Memilih satu huruf vokal. What is the huruf vokal? Huruf vokal is U and E. Kan? A, E, I, O, U. Yeah, okay. So how many vocals are there? How many vowels are there? Okay, 2. So our probability of getting a vowel is 2 over 6, but you need to give your answer in the simplest form, which is 1 over 3. Okay, semua jawapan akhir harus di dalam bentuk yang termudah lah. Okay, it should be in the simplest form, 5 over 8 or 1 over 3 in this case. Okay, so yeah. Okay, a common mistake, another common mistake is dia tengok vowels saja. Oh, there are 2 vowels, but I only want to choose 1. So it's 1 over 2. No, you don't. Okay, because inside the box, inside the jar, there are 6 letters. You may not be choosing a vowel. What if you get N? Okay, N is not a vowel. So that's a different story altogether. Okay, so remember, think of the sample space. Okay, sample space is every possible thing there is. Okay, all right, a very common one that we are always used to. Sorry, I need to erase all this. So annoying. Okay, so a very common question that you are always going to see, okay, whenever we talk about probability is bila kita guna dadu. Okay, all of you have seen a dice before? Have all of you seen a dice before? Sebab semua pernah main Jutaria. So, when you have a dadu, okay, when you have a dice, okay, you will definitely have to have 6 sides. Okay, there are 6 sides in the dice. So what are the numbers that you can get from a dice? Which is 1, 2, 3, 4, 5, 6. So question number 6, a fair dice is flipped once. Okay, kamu lambung sebiji dadu satu kali saja. What is the probability of obtaining a score greater than 4? Let's talk about the sample space once again. Okay. So our sample space is, what are the possible outcomes that can be? You can have number 1, you can have number 2, you can have number 3, you can have number 4, you can have number 5, you can have number 6. Okay, and this is, there is an importance. Kenapa orang, why does this question they must put the word fair? Okay, because this is an ideal situation. Most dices are unfair, okay, actually, because of the way they're built. Okay, they may be heavy on one side. A fair dice means you have an equal chance of getting any number. Plus, you won't have a dice that, yeah, you don't have the kind of magic dice that akan, when you roll, then it will just stand on one pointed end. Okay, not like those like movies and you see, oh, stand on one pointed end. It's like, okay, no number. Okay, not that kind of. Okay, we're talking about real world. So fair dice is a dice that has an equal chance of getting any number. Okay, kebarangkalian kamu untuk mendapat sebarang nombor adalah sama. Okay, so the score greater than 4 is our event. So A is greater than 4 is 5 and 6. Because we don't want 4 lah. Okay, we don't want 4. So probability of getting this event is how many events are there? 2. How many is our sample space? 6. And once again, our answer should be always in simplest form. Okay, 2 out of 6. Okay, I know I'm taking a very long time to answer these 3 very simple questions. This is all one mark questions, honestly. Okay, but I want you to really understand the difference between a sample space and an event. Because when we go and talk about the rest of this one, okay, I don't want to come back and say and revise with you. Apa itu sample space tu? Apa itu event itu? Okay, you need to know the difference between sample space and event. Event is something that the question will ask. Sample space is every possible things there are. Okay, and your event must never be more than the sample space. Okay, let's take a look at slightly more difficult questions. Oh, okay, question number 7. This is Shane's favorite word. Find the number of code words that can be formed from the letters of the word exactly. Okay, if you look at this question, find the number of code words can be formed from the letters of the word exactly. How many letters do you have? 1, 2, 3, 4, 5, 6, 7. If you want to form a code word, okay, so the answer for this will be 7 factorial. Okay, where have we seen this? We've seen this in the previous subtopic. You have 7 letters, you want to rearrange all those words together. So it is 7 factorial, okay, which will give you 5040. Okay, so, and the good thing about this is the number of our sample space. Are you really going to, let me just check my 7 factorial. 7 factorial. Yeah, 5040. Kita punya sample space ada 5040. Okay, so we're not going to do like what we did in the previous one, list down all the sample space. That's nonsense. Okay, that's crazy. Okay, you cannot do that. We can do that kalau dia punya sample space sikit saja. But in our case over here, our sample space is so big. Okay, our sample space is 5040. Okay, I'm not going to this one. So I just want to mention over here that this is actually the number of our sample space. Cukup untuk kita mengetahui. Okay, so if one of these code words is drawn at random, okay, kalau kita pilih salah satu daripada code word daripada 5040 ini, find the probability that it is a word that ends with a consonant. Okay, now think about this. If it is a word that ends with a consonant, how many letters are there? 1, 2, 3, 4, 5, 6, 7. Okay, this is where the combination of permutation plus probability comes in. Okay, the last one is a consonant. Okay, how many consonants there are? X, C, D, L, and Y. Okay. So these are the possible consonants there are, but we only have one place to fill. So this is 5p1. Okay, 5p1. And then what do we do with the rest? We have 6 factorial. Oh dear, hold on now. Okay. 6 factorial. What do? We multiply. 6 factorial multiplied by 5p1 will give you, oh dear, 6 factorial times 5p1 is 3,600. Okay, so there are 3,600 ways to form a code word di mana yang last itu adalah consonant. Okay, so what is the probability of this happening? The probability of this happening is 3,600 over 5040. 600 divided by 5040 will give you 5/7. Okay, so this is an example of a question that uses both permutation, combination, and probability. And this is a very commonly asked question. Okay, so that's why we need to always study this before we do probability. Okay, because you want to find 3,600 words for the event. You finish your MS paper, so belum tentu lagi kau sudah dapat 3,600 code words. Okay, that's why we use permutation. The number of ways there are. Okay, so this is enough, 3,600. Let's look at question B. That begins and ends with a vowel. Okay, begins and ends with a vowel. So 1, 2, 3. It's funky with my pen. 4, 5, 6, 7. So the last one is a vowel, and the first one is also a vowel. Let's consider the first one first. How many vowels there are? A and E only, right? So this is 2B1. Once you put one vowel over here, the other one will be just one way left. Okay, times how many letters are there left? 5. And you want to permutate all because kita mau pilih-pilih. Okay, so 5 factorial. So the number of ways for this to happen will be 5 factorial times 2p1, which is 240. Okay, 240 ways. Okay, so the probability of this, is 240 over 5040. Okay, which will give you 1/21. Just double check. 240 divided by 5040. Yeah, 1/21. Okay, so this is an example of a question that that uses both permutation and also probability. Okay, but the probability part actually is very little. All you have to know is just how many sample space, and then after that you use permutation to find out how many ways there are to form the event that you want. Okay, so this is an event. Event is the words that end with a consonant. The event is the word that begins and ends with a vowel. Okay, but we combine this together with permutation. Okay, to do this. Okay. Any questions so far? No. Okay, if there's no questions, I want to do question 8 now because there's also something else that I want to point out over here. Okay, so you have question 8 that says an unbiased dice is tossed 3 times. Unbiased means it's a fair dice. Remember that in the previous slide we were talking about fair dice. Okay, so an unbiased dice also means the same thing. Okay, it is a fair dice. That means every possibility of you getting any answer is equal. Okay, hold on. We rub all this off first. Whether there's a bigger I've done this much earlier. All right. So find the probability of obtaining a total score of 18. Now think about this. If you want to score 18, when you throw 3 times, your total score is 18. That means the first one must be 6, the second one must be 6, the third one must be 6. No choice. Okay, so the probability of this happening is 1 over 6 times 1 over 6 times 1 over 6. Because first time you throw, you get 6. What is the probability of getting number 6? 1 over 6. Okay, so 3 times this will give you 1 over 216. Okay. Question B, total score of 3. If you're going to get a total score of 3, okay, there's only one way in which it can happen. Is if every dice that you throw, you get 1, 1, and 1. What is the probability of getting number 1? It's also 1 over 6 lah, because there's only one number 1 in the dice yang ada 6 muka. So 1 over 6 times 1 over 6 times 1 over 6, which is 1 over 216. Okay. What about question C? A total score of less than 3. Okay, ask yourself, is it possible for you to get a total score of less than 3? Okay, cannot, because you throw the dice 3 times, right? How can you get anything less than 3? So this is what we call the probability of 0. It's never going to happen. You throw one dice 3 times, if your score is less than 3, then you better go and find somebody, because there's probably a ghost in the house. Suddenly you got a score less than 3. Okay, or a total score of not more than 19. Tidak lebih daripada 19. The probability of this is 1. Because no matter how you throw the dice, your answer is definitely not going to be more than 19. Okay? So the probability of this is 1. Sometimes you don't have to count on it. Tidak payah dikira ini. Sebab ini logic. You cannot get less than 3. You cannot get more than 19. Okay? Actually, this question is wrong. It should be 18. But never mind. Okay, fine, 19 lah. Not get more than 19, because macam mana kau mau lambung dadu kan yang ada 6 saja, 6 campur 6 campur 6, maximum is 18. So confirm your answer is going to be not more than 19, tidak lebih daripada 19. So kebarangkaliannya adalah 1. Okay, somebody asked me, what if it's 110? Please tell me how you're going to get a dice with the answer 0. Cuba kau lambung dadu dan dapat nombor kosong. Bolehkah? I know. Wow. Okay. Sorry lah. Unless you are the kind of people that play Dungeons and Dragons. Okay. Dungeons and Dragons dice is a different thing altogether. Okay. Dungeons and Dragons got about 18 sides altogether. That's a different kind of dice. If you're talking about normal dice, guys have, oh no, okay, wow, semua dalam kelas ni budak baik kan, tidak pernah berjudi. Okay, here's another question. What if my dice is bulat? Okay, if your dice patience, I'm recording. Okay, Okay, so if your dice is bulat, it's not called a dice. It's called a sphere. It's called a ball. It's called a ball bearing. Okay, how to know how many times you roll? The question will tell you how many times you roll. Okay. Whenever we talk about a dice, guys, okay, fine. You're forcing me to do this. Okay, whenever we talk about a dice, good thing that my mahjong set is just down here. So, okay, whenever we talk about dice, we talk about this kind of dice lah. Okay, ini dadu. Okay, take a look. There's number 1, there's number 2, there's number 3, there's number, where's 4? 4. Okay, there's number 5, and there's number 6. Okay, there are only 6 sides. Okay, and the dice will definitely not fall like this. Dia tidak akan jatuh, and then it will always land on one side like this. Okay, it won't land like this. Dia tidak akan jatuh macam ni, like you know, like on the border macam ni. Okay, whenever we talk about maths questions, we talk like that lah. Okay, we don't have all these bizarre situations. Okay, and usually dice is cube lah. Okay, cube in size. If you have a round dice, it's not called a dice, it's called a ball. Okay, or a sphere. Okay, so yeah, and as you can see, there is no number 0. Okay, the smallest number is number 1. Okay, so yeah, I think you guys have too much BBL until you have forgotten what a dice looks like. So oh dear. Do you also want a demonstration of what a coin looks like? Okay, oh dear, it's so funny that I'm getting very worried. Okay, question number 9. 10 cards. Okay, you have 10 cards, number 1 to 10. Okay, that are placed in a hat. Okay, so Raj pulls out a card randomly from the hat. Find the probability that the card is number 7. Okay, so let's talk about this. So to make things simpler now, okay, let's talk about how many is our sample space. Our sample space is 10 because there are 10 cards only. Okay, the event that we want, okay, I'm going to call this event A. Event A is pulling out number 7. How many number 7s are there? There's only one number 7. So the probability of the number 7 being pulled out is 1 over 10. Okay. What about B? Has an odd number. So let's call this event B. How many odd numbers are there? Odd number is nombor ganjil. Nombor ganjil is 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. Okay, 5 lah. So there are 5 odd numbers. So what is the probability of getting an odd number? Is 5 over, how much is our sample space? 10. 5 over 10, simplify, will become 1 over 2. All right. Question number C. A different event altogether has a number smaller than 7. Okay, smaller than 7 numbers. Okay, so what are the numbers that are possible? 1, 2, 3, 4, 5, 6. Okay, so let's call this event C. The number of cards that are smaller than 7 is 6. So the probability of getting a card that is smaller than 7 is 6 out of 10, which is 3 out of 5. Okay, so this is a very common question lah. Okay, a very common question that is usually asked at very paras rendah lah. Okay, because very simple. This is actually a maths question lah. Yang kita jawab tadi bahkan yang exactly ini. This is a standard maths question. Okay, but this question that we just answered, question number 9, this is a very standard maths question. Okay, maths SPM lah. Okay, very simple probability that everybody should know how to do. All right, let's take a look at question number 11. How many different total amounts? Okay, this is maths one. How many different total amounts can you form from 2 currency notes if you have 5 currency notes of the denominations RM1, RM2, RM5, RM10, dan RM50? Obviously now we don't have the RM2 anymore, but never mind. So how many different total amounts? Okay, maksudnya daripada 5 ini kan, kamu pilih 2. Okay, then how many amounts can you get? So contohnya, I terambil RM1 dan RM2. So that's RM3. That's one event. That's one sample space. Another one is RM1, RM5. Okay, so the number of ways, okay, the number of ways will be if I have 5 and then I want to choose 2. 5 choose 2, yeah. Okay, 5C2 lah, if I'm not mistaken. 5C2. Okay, so there are 10 ways. Let me just check. Should be correct. Yeah. Okay, there are 10 ways altogether. Because saya pilih RM1 dan RM2 dan saya pilih RM2 dan RM1, doesn't matter. Okay, the arrangement doesn't matter. Okay, it is just how many ways. So there are 10 ways for me to choose 2 notes lah. So find the probability that the 2 notes you have picked has an amount greater than 12. Okay, let's take a look at how many that is possible. So I choose 1 and 10. Oh dear, what any? Sorry, okay, so 1 ringgit and 10 ringgit. Okay, tidak boleh because it's not greater than 12. So tak boleh. Okay, maybe 1 ringgit and 50 ringgit. Okay, that's one. What about another one is, come, give it to me lah. What else can we get? That lebih daripada 12 ringgit. Sorry, looking at the chat. Okay, 5 and 10. Apa lagi? 2 and 50. 5 and 50. 50 and 10. Okay, 50 and 10, 10 and 50 is the same thing. What else? Any more combinations? Greater than 12 means 12 ringgit tidak termasuk. You cannot do 10 and 2. Okay, 10 and 2 is not possible. Okay, so yeah lah, there's no more lah. There's only 5 lah. Okay, there are only 5 combinations that will give you a total of more than 12 ringgit. So what is the probability of this happening? The probability of this happening is, how many are there? 5. 5 ways over how many altogether? 10 ways. So it is 1 over. Okay, so this is another example of using combination and probability combined together. Okay, but this is only the probability of one event. Okay, remember, we haven't talked about probability of 2 events. Okay, we'll come to that in a while. All right, one last question, I think. Okay, number 13. Okay, I want to do number 13. Okay, of the 120 members of a sports club, okay, 36 members play ping pong, 30 members play ping pong and badminton, and 81 members play ping pong or badminton. Wow. Okay, so find the number of players who play badminton. Does this make sense? Hold on, let me just check. Okay, so when we do this, okay, let's think about this. Okay, so dia cakap there are only 36 members that only play ping pong. Okay, then there are 30 members that play both ping pong and badminton. Okay, and then there are 81 members that play ping pong or badminton. Find the number of the members who play badminton. Okay, then calculate the probability that a member chosen at random plays badminton. So this one a bit later lah. Okay, so this one now we may have to do what we do a subset lah. Okay, subset like this. Okay, so if this is ping pong, okay, and we call this badminton, okay, remember there are 120 altogether. Okay, that's the very obvious one is 30 members play both ping pong and badminton. So in here is 30. Okay, over here is 36. Okay. There are 81 members that play either ping pong or badminton. Okay, so how many people do you think play badminton? Let me see. Minus what? Oh, sorry. Actually, my mistake. Yeah. This one is not correct. Ini 36 ni salah ni. If there are 36 members that play ping pong, means this set here, there are 36 people altogether. Okay? And there are 30 members that play ping pong or badminton. Oh, sorry. 30 members that play ping pong and badminton, this one is the intersection. Okay, so that means if there are 36 people over here, means over here there should be only 6 people. Because this set has 36. Okay, 81 members play ping pong or badminton. So how many people are playing badminton? As in, termasuk this 30 orang lah. Okay, how many people are here altogether? So how? If 81 members play ping pong or badminton, no, not 51. If 81 members play ping pong or badminton, I mean selain daripada ini 30 orang, okay, 6 campur how many badminton there are, salah satu, okay, is 81 members. So over here will be 7. No, not 8. 81 minus 6 is 75. Oh yeah, correct lah, 75. 75. Correct. Find the members who only play badminton, okay, which is 75. Then calculate the probability. The probability will be 75 out of 120 lah. That's normal. 75 over 120, sorry, 75 over 120 is 5 over 8. Okay. So this is another example, okay, another example where we use set, but I have found that usually people who, questions that use set usually involves maths SPM. Okay, usually admits we will use computation, combination. So itu yang betul-betul admit sahaja. Okay, but it's also good, especially if you like set when you were studying in Form 4. This is very important. Okay, to know how to translate this sentence into set notation. All right. Okay, let's talk about probability of two events. If you take a look at your textbook, okay, if you take a look at your textbook in page 170, as I mentioned just now, there are two types of ways to find probability of two events. One is if both events happen at the same time. Okay, and then secondly is if salah satu saja daripada dia punya event yang berlaku. Okay, if both events happen at the same time, then we usually use multiply. But if either one, okay, kalau salah satu sahaja yang berlaku, we call this an A or B set or B probability. Okay, so you have two events. Okay, so the first situation is the first situation is where you have a probability of both happening. So this is probability of A and B. Okay, if you remember when you were doing set, ini ada intersection, kan? Intersection is A dan B berlaku. Okay, A and B happening. The probability, the second one is either one of these is happening, A atau B. Okay, and for this one, the probability of A or B happening, there is a formula, which is the probability of only A plus the probability of only B minus the probability of A and B. Okay, we will come to this in a while. Okay, but I want to settle this first one first. Okay, so this first one is easy. Kalau A and B, masih darab saja. Okay, so let's look at question number 15. Okay, I want to take a look at question number 15 as an example first. Okay, question number 15. The Road Transport Department recorded a total of 500 accidents in a certain state for the month of December 2006. Okay, 350 accidents involve motorcycles, 310 accidents involve motor cars or motorcycles. 200 accidents involve both motor cars and motorcycles. Okay, so write down the probability that if one of the accidents in the state for that month is chosen at random, it involves a motorcycle. Okay, so let's take a look. How many that involve motorcycle only? So it's 350 over 500. Okay, because ini motorcycle saja. So I'm going to call. Okay, let's do this. Kalau motorcycle, we're going to call this. Sorry. Let's call this M for motorcycle and alamak. Motorcycle and motor car. Okay, M for motorcycle and C for car. Okay, so I'm going to call M for motorcycle and C for car. So this is probability of motorcycle. Okay, it's 350 because there are 350 accidents involving motorcycles over 500 altogether. Okay, that's our sample space. So this will give you 0.7. Okay, the probability of motor car or a motorcycle, okay, which is given here. 310 accidents involve motor cars or motorcycles. Okay, so this is called P motor car or motorcycles or motor car is 310 over 500. Okay, which will give you 0.62. Okay. And then the third one is a motor car and a motorcycle. So this is motorcycle and and a car. This one will be, how many are there? 200. Okay, involve both motor cars and motorcycles. So it's 200 out of 500. Okay, which is 0.4. 0.4? Yeah, 0.4. Okay. Now I want you to notice a few things. Number one, in this question, all the number of events is already given. Okay, so they just want you to try to translate this into math notation. Secondly, notice that I'm now using probability in terms of decimal places. I can use 7 over 10, 34, 31 over 50 also can. Okay, 2 over 5 pun boleh. Okay, so sometimes it varies. Dia berubah-ubah lah bergantung kepada keadaan. Sometimes we use decimals, sometimes we use sometimes we use fractions. Okay. Most of the time, especially for paper 1 questions, for probability, we will use fraction. But there are sometimes where the fraction is so complicated that sometimes it's better to use decimal. It's totally fine. Okay. But the question that hasn't ended, the question is then calculate the probability that it involves a motor car. Okay. Now, if you take a look at the formula that I gave just now, if I still remember where this is the formula. So the formula is the atau, okay, if the event A or B is event A plus event B minus event A and B. So if I'm going to change this to motorcycle and car. So the formula states that the probability of motorcycle or car, okay, equals to the probability of motorcycle plus the probability of car minus the probability of motorcycle and car. Okay. Now, based on this, let's put in all the values. Okay, we have here. Okay, PM, the probability of motorcycle is 0.7. So over here is 0.7. Let me see. What else do we have? Probability of motorcycle or car. Okay, is 0.62. Okay, M or C lah. M or C is over here. So it's 0.62. Okay, let's continue. What do we have left? We have probability of motorcycle and car is 0.4. Okay, so this is 0.4. So minus, this is what we want to find, probability of car. And this one becomes a very simple math already. 0.62 minus 0.7 plus 0.4. Okay, so how much is our PC, probability of car? Can you calculate for me, please? Yeah, can also. All right, so this will be 0.32. Okay. Now, this is a long way of doing this. And the reason why I want you to do this is I want you to get familiarized with this formula, which I think is also taught to you in SPM maths. Okay, but I want you to get used to this formula and that it can be interchanged. But you need to know what the symbols mean. Okay, or and perkataan atau and dan, okay, and okay, plays a very important role. Okay, when we talk about probability. Or means salah satu, and means dua-dua kau kena pilih. Okay. Now there is another alternative that you can consider, which doesn't involve the use of the long formula. And actually, Timothy has found out the way lah. Okay, 160 over 500. How do you get 160? Okay, you know what? Never mind, never mind. It's okay, it's okay. Let's continue. Okay, we're going to go into slightly tougher questions. Number 17. Okay, number 17. Interesting. Okay, so find how many 4-digit numbers can be formed from the digits 2, 4, 6, 7, 9 without repetitions or digits. Okay, so this is a case of permutation. Okay, you have 5 numbers, you want to choose 4, and you want to make the numbers. So it's very different. Okay, so let's start off. This will be 5p4. Sorry. Okay, so this is 5p4, which will give you how much? 5p4, 120 altogether. Okay, so you have 5 numbers, but I only want to choose 4, and I don't want them to repeat. So it's 5 permitted 4. So our sample space is 120. Okay, now if one of these numbers is chosen randomly, that means daripada 120 nombor ini, kau mau pilih satu nombor lah. Find the probability that it is greater than 7,000. Okay, now let's talk about the number of ways it can be formed first. So greater than 7,000 is this number can only be number 1, can only be number 7 or number 9. So this is 2p1 times. How many ways are there to fill in this one? Okay, lepas kau letak satu nombor, kau ada berapa nombor lagi? Kau ada 4 nombor lagi kan? Dan berapa tempat kosong? 3. So it's 2p1 times 4p3. So 2p1 times 4p3 is 48. Okay, so the probability of this happening is 48 over 120, which will give you 0.4. Yeah. Okay, so this is a classic example, okay, of using permutation and probability together. Okay. Question B, find the probability that it is an even number. Okay, let's consider even number. Kalau kau ada 4 tempat kosong, because we only want to form 4-digit numbers, what numbers can go in at the back to make it an even number? It can only be 2, 4, or 6. So 3p1, because there's only one place for you to put. Times 4p3 lah, this is standard. Because lepas kau letak satu nombor sini, ada 4 lagi nombor dan 3 tempat kosong saja. So 4p3. Okay, so this will give you, how much is this? 4p3 times 3p1, 72. Okay, so the probability of this happening, I'm going to call this probability B. This is probability A. Okay, probability B is 72 out of, how much is our sample space? Sample space is found at the beginning. So 120. So 72 out of 120. I wonder whether there's a 0.6. Okay, the probability of this is 0.6. Now, greater than 7,000 and an even number. Okay, so we want both of these to happen at the same time. Okay, so greater than 7,000 and an even number. Yeah, okay, greater than 7,000 and an even number. Hold on, let me think about this first. Okay, let's figure out lah. Okay, we want it to be more than 7,000 and an even number. So kalau kita letak ini, okay, behind can only be filled by either number 2, 4, or 6. Okay, and in front can only be filled by either number 7 or number 9. Sorry, 2, 4, or 6. So this is, this is 3p1. Okay, this is 2p1. Now, once you have put in both this one, okay, then you have 3 numbers left and you only have 2 places lah. So this is 3p2. Okay, so how many ways are there altogether? So 2p1 times 3p2 times 3p1, 36. Yeah, 36. Okay, so the probability of this happening, the probability of this happening is 36 out of 120. Wow, so teruk. Sorry, wait lah. Okay, so the probability of this happening is 36 out of 120, which I wonder if it's about 0.3. Do it. Sorry, 0.3. Okay. So again, this is how we use permutation and probability together. Okay. Kind of the most difficult kind of question in this particular section. Okay. But we're not done yet. Then find the probability that one of the 4-digit numbers formed, chosen at random, has a value of greater than 7,000 or is an even number. So this is again where we use the formula that we did just now. Okay, or so we have greater than 7,000 or even number. So we add the two together separately minus the intersection. Okay, so so the probability of let's call it A or B lah. Okay. Either my pen is running out of ink or something is happening. Okay, so this is probability of A, 0.4, plus probability of B, 0.6, minus 0.3. Okay, so 0.4. Yeah, I think I'm running out of battery. I need to change battery. Plus 0.6. Okay, minus, this is the N. Okay, greater than 7,000 and an even number, 0.3. Okay, so this will give you 0.7. Okay, so yeah, so that's how we would do this. Okay. Yeah, there is a condition for this, but never mind. Okay, so actually there are many more questions lah. Okay, if actually I find that the textbook questions, there are more interesting textbook questions. Like for example, this lah. Okay, this one actually is how do I say this? This one is actually more just numbers. Okay, which actually tests you on whether you understand. You know what this means? The probability of A and B, the complementary sign. Okay, yeah, I can't remember what this is in English. Okay, but never mind. Don't worry so much about this. Okay, like I said now, when we talk about probability, the basic concept that you need to understand is the idea of sample space and the event. Okay, and we find that in recent years, questions about probability have been involving a lot more questions that involve permutation and combination. They try to combine both the topics together. Okay, ada juga lah yang soalan yang lebih senang sikit. Okay, but I think it's good practice for you all to consider, good for revision also. Okay, to do questions that have to do with permutation and combination. Okay, so give number 18 a try. Number 18 is almost the same as number 17. Okay, the two events is one is value greater than 7,000, second one is even number. And then values greater than 7,000 and in the even numbers. And then lepas tu find the all. Okay, which is basically just menggunakan this formula. Yeah, okay, this formula. Okay, sorry. Okay, this formula. PA plus PB minus the intersection. Okay, three of these you have to find manually. Okay, you cannot just multiply it like that. Okay, because that's a different story altogether. Okay, so the probability of two events happening at the same time, you have to find both the events and then after that divide by the sample space. Okay, it's slightly different than the next subtopic. Okay, which we will come to on when is our next class, Thursday. All right, so before I open this time for questions, so in your module, what you can do is you can start by doing all the 7.1 questions. Okay, 7.1 all the way from number 1 to number 8. There are 8 questions over here in this first half. The second half, you can do from question number, you can do exercise 7.1, exercise 7.2, yeah, you can do 7.2. Exercise 7.1 and 7.2 for the time being. Yeah, exercise 7.1 and 7.2 and questions number 1 to number 8. Okay, I will give the answers in a group after this. Right? Okay, any questions from anybody? You can, sorry, I'm going to stop the recording.